Okay, the board, listen. Because the AP test writers are so clever at creating new problems, it's not helpful if I just do example after example, because then all of you get the idea that as long as you can follow my examples, you'll be able to do AP problems. Then when I give you a full-blown AP test, you're like freaking out. I'm serious. Because you're like, wait a minute, none of these problems look like what we've talked about. Like you would have been trained improperly. So what I'm constantly trying to train you to do is what you're going to need in college, which is solve the problem conceptually, not by knowing a problem. So this problem is all about the mean value theorem. So somebody raise your hand, pick up 2 points, start talking about what we should do here. Please.
So the first thing we have to do is find the average rate of change. To do that, you have to plug in pi over 2 and 3 pi over 2 to find like the y coordinates.
Well done. So there's this formula here for f, and we've got to find the average rate of change of f, or secant slope, between the 2x coordinates that they gave us that define the interval. So we've got to do this. 2 points for math. So I've got to find the sine of pi over 2 divided by 2. And I have to find the sine of 3 pi over 2 divided by 2. Okay, is there anyone in the room who feels like lost as to why we're doing that? You must keep track of the why of each step. One thing I haven't said a lot this year is please don't guess in this class. Don't be doing homework and just go, well, I think this is what I should do. All you will end up doing is teaching yourself incorrectly. And when you take a test, you'll feel really lost. You'll be like, I can't remember, do we do this or do we do that? If you don't know the reason why you are taking a step, come talk to me. Find out the real reason. You have to know why you take each step. So, anyone having trouble knowing why we have to do this? So the mean value theorem, it says we've got this function, and there's some value, this is an x coordinate, there's some x in this interval for this function that will satisfy the mean value theorem. What that means is whatever this happens to look like, and I don't know, so I'm going to cheat a little bit because I've done the problem before, but just pretend f looks like that. Well, here's x equal pi over 2. And here is x equal 3 pi over 2. So that's what they're describing. Mean value theorem states that on this interval, and as far as we're concerned, when you're using the mean value theorem, because you're only looking at an interval, you do not look at anything else. You basically pretend that the function starts here and stops here. There are no points anywhere else. You need to find the average rate of change between these 2 points, which means we need to know the slope of this secant line. We've got to find this secant line's slope, which means change in y divided by change in x. So we don't know this y coordinate. We need to find it so we can find how much y changes from here to here. And then we can divide by how much x changes. Does that help? That's why we're doing this. Because we have memorized that mean value theorem states that the slope of this secant line is going to be the same as the slope of one of these tangents. Please. Oh, because I used the formula. So the formula says sine of x over 2, and the x value is pi over 2. Does that answer it?
Yes.
2 points for Hannah. Parker, please.
So I was just looking at this. That's part of the unit circle. That's a
half of a unit circle, isn't it? Because that's the top half, pi over 2. Do you think this is a unit circle problem too?
2 points for Parker. You're heading in the right direction. All eyes on me, everybody, look. Okay, I want you to change your thinking just a little bit. Raise your hand, collect some extra credit. Raise your hand if you know what 7 times 5 is. Hand. 7 times 5, Luke?
35.
How many knew it? Point. Raise your hand if you know what 8 times 9 is. Hands. Go. 8 times 9. Go right. How many knew it? Point. Let's keep playing. This is fun. Raise your hand, please, if you know what 3 times 8 is. Hands. 3 times 8. Jane? Point. Keep marking them down. We'll keep going until you're sick of it. 5 times 6. Hands up. 5 times 6, Savannah? Savannah seems bored. 30 points. Okay. Look at me. Look, come on. Focus. Focus. Okay, as quick as you can raise your hand and answer those questions on the AP test, that's how fast you have to be able to do this. Okay, dividing by 2 is the same as multiplying by the reciprocal. So dividing by 2 is the same as multiplying by 1/2. So this becomes the sine of pi over 2 multiplied by 1/2, which means we have the sine of pi over 4. Does anyone need me to talk through that logic again? You will do this all year long, this divide by the reciprocal. It happens a lot. If you do the same thing here, this is going to become the sine of 3 pi over 4. Okay, the point of our silly little game where you all earn 4 points rather rapidly is that as quick as you can tell me that 7 times 9 is 63. 7 times 9 is 63. On the AP test, hey, on the AP test, you have to be able to look at this and go, oh, sine of pi over 4, and just know. Okay? Look at me. Don't bail. Focus. Come on. Like, you have to do it quickly. So I'm going to show you the way I have memorized this information so I can recall it quickly. I don't care how you memorized it before. If you memorized it before and you did it efficiently and quickly and you remember it, stick with it. But if you hated the unit circle, then dump that and listen to me. Okay? I'm going to show you a method that to me is really easy. It's really fast. It's really easy to understand. Okay? So if you like your previous method, keep doing it. If you don't like the previous method, use this method. But if you can't do this quickly on the AP test, you are throwing away way too many points. Okay, just easy points. So here we go. I want to find the sine of pi over 4. So put this in your notes. You'll have a good record of it. For the unit circle, you simply have to first, the circle, look, I don't want you thinking this is a unit circle problem. It's not. That's like saying some problem is a times table problem. There's no times table problems. There are problems where you have to know the times tables. There are problems where you have to know the unit circle. But they're not unit circle problems. Okay, first key to the unit circle memory aid is knowing how to find the angles. Okay, finding the angles goes pretty quick. All the way around is 2 pi. So if we rotate the complete circle, we have rotated an angle of 2 pi. So points for the whole room. Don't think too hard. Where would a rotation of pi be? Hands, come on.
180.
How many knew it? Point. Where would a rotation of 1/2 pi be? Come on, hands. Where would a rotation of 1/2 pi be? Just tell me the number on the clock. If you have to look at the clock, it's fine. Perfect. If I were taking the AP test as a student, I would go to Walmart and I would purchase a watch that looks like that. Because it wouldn't cost me more than, I don't know, how much is a watch like that going to cost at Walmart? How much? I can't hear. $10. $14.99. Yeah, I'm serious. Like I would buy a watch. Perfect. It is all set. Magic chip, get my sledgehammer. Bag. That would be a good trick though. Wish I could do that trick. Look. Here's the unit circle. It's legal to take into the test. Unless you want a timer anyway. Really, I'm not kidding. Now that they might, you know, I can't advocate this. That would be cheap. But this is fair. Hey, look, I'm serious. This is fair. Just use this. So, hey, just wave at me. Is anyone having trouble finding the angle? Just wave if you're having trouble finding the angles. Cool. On a clock, this one right here. So here's the 1 on the clock, here's the 2 on the clock. This is pi over 6. This is pi over 3. And then in the middle, where there's no number on the clock, that's pi over 4. Okay? I will never give you a quiz where I give you a sheet and it says here, fill out the whole sheet. I know you've done that. It's useless for this class. Look, don't do that. Just count. So, points for the whole room. Well, let's do an example. Like if I have to go find 3 pi over 4, I just count. There's 1/4, there's 2/4, there's 3/4. That's it. If I have to find 5 pi over 6, I just count. 1/6, 2/6, 3, 4, 5. If I have Ada's watch, it makes it even easier to count because the marks are on the watch. Okay, all of the 6 marks are the clock. It matches up perfectly. The 45s aren't on the clock because they're just the halfway points. So they're easy. I don't ever count thirds. If you try to count thirds, you often will make an error, so I always count 6. Like if I have to find 5 pi thirds, I'm going to count 10 pi 6. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There it is. Okay? Wave if you need me to give you more examples of how to find the angles. Just wave at me. No one's waving. Cool. So that part is easy. Just use your watch. Okay? All you have to do now is memorize a few simple values. Here are the values in order. You have 1. You have the square root of 3 over 2. You have the square root of 2 over 2. And I don't know if you've seen it this way, you have the square root of 1 over 2 and you have 0. Okay, use your common sense. Raise your hand, please. I would like you to vote. Which of these would your common sense tell you is probably the largest value? Just hands up. Come on. Which of these 5 would your common sense tell you is the largest value? Okay, everybody who's willing to participate in our little game here. Andrew. How many vote for 1? 2 points. Look at the 3 in the middle. You've got the square root of 3 divided by 2. You've got the square root of 2 divided by 2, and the square root of 1 divided by 2. Which of those 3 would you expect to be the biggest? Hands up. Which of those 3 is the biggest, Michaela? How many agree? Point. 2 for Michaela. Which is the smallest of those 3? Hands up. Which is the smallest of those 3? So Nathan?
Square root of 1 over 2.
How many agree? Point. Okay. If I'm looking for the sine of 5 pi over 6, Okay, I'm working an AP problem. It's not a unit circle problem. It's just I'm working a problem, and now I need to use this memory aid to remember this. All you have to do is find the angle. So I use my watch, where I draw a quick circle, and I find the angle. Okay? Sine, the way I remember, is sine has the I in it. The I goes up and down. So the sine is always an up and down distance on my little circle. Sine is the up and down distance. Okay? Well, there's this distance, there's this distance, and there's this distance. Don't think too long. Please raise your hand and tell me which of those three lines is longest. Hands up. I'm trying to point out this is not a hard concept. Brendan.
The green one.
How many agree? Point. Okay. Look at the numbers. Look at the numbers. The green line is root 3 over 2 long. The purple line is root 2 over 2 long. The pink line is, this is just 1/2. It is way easier. Okay? I promise, it's way easy. Just look at the picture. Don't think, just look at the picture. I need the sine of 5 pi 6. So I draw a circle, I count, and I go, oh, sine is the up and down. Hey, it's the short one. Question? Cool. If I need to do this, sine of 5 pi over 3. I count to here. Sine is the up and down. Well, that's the long distance. They come in pairs. Look. The sine is the up and down distance. The cosine is the back and forth distance. These two always come together. Okay? So if the sine is the long distance, the cosine is the short distance. That's it. The sine went down, so it's negative. Question? That's how I remember the value. So that's my method. I feel like it's really fast, it's really easy, it's really quick, it's really efficient. You don't have to really think a lot. You don't have to memorize a whole sheet. Good. Okay. So back to the any questions here? Like, anybody want me to do another example? Cool. So back to here. I need the sine of pi over 4. So new page real quick. So I draw my circle. Pi over 4 is the middle spot. So here's pi over 4. Okay, at all of the fourth angles, the sine and cosine values are always the same. They're always root 2 over 2. Sine is the up and down. So the sine of pi over 4 is root 2 over 2. Just say it out loud, please. Am I moving in is this a positive direction or is this a negative direction? Positive. So this is positive. I also need to find the sine of 3 pi over 4. So I count 1/4, 2/4, same as pi over 2, 3/4. Sine is the up and down distance. Just say it out loud, please. Is the value positive or negative? Say it. Positive. All the fourth angles, the values are always root 2 over 2. You do not need to be terrified of the unit circle. You don't need to get sick to your stomach. You don't need to throw up every day when you get the unit circle out. Just do this, okay? It's really easy.
Every day. I see it and just gag.
It's really easy. No need to gag. Okay? Question.
Right now, it happens over here.
So back to here. So this table, which has gotten a little bit messy, we figured out that this value here is root 2 over 2. This value is root 2 over 2. Questions? Okay, everyone raise your hand, please. For this function, what is the average rate of change? Please talk to each other, raise your hand. What's the average rate of change from here to here? Hands up, come on. What's the average rate of change? I'm going to copy this page over. What's the average rate of change on the interval that's specified? Average rate of change means, got to get this memorized. Like you got to get things coming to your mind quicker than they are. Okay, average rate of change means change y over change in x. So what's the average rate of change, Devin, from here to here?
0.
And why?
Because it's root 2 over 2 minus root 2 over 2.
Perfect. If we're looking for the change in y, there is none. The y value does not change from one point to the next. The function's not changing, so there is no rate of change. The rate of change is 0. How many knew it? 0.2 per Devin. So let's erase some stuff here now. So we know we've got our secant slope has a value of 0. 0 over pi over 2, but pi over 2 doesn't really matter. Okay, please memorize. You cannot find the slope at an endpoint. You can't find a slope at an endpoint. Because the mathematical way that slope is found is this picture here. If I want to find the slope at a point, I have to find a slope to the right, slope to the left, make those slopes really short to identify the slope in the middle. Okay, look up. Okay, if all I have is an end point, I can't make a slope to the left. Like if I'm right here on the picture, and I want to find the slope right here, I can't mathematically do it. There's no way to go left. If I'm over here, there's no way to go right. So memorize, you can't find the slope at an endpoint. Therefore, you cannot satisfy the mean value theorem at an endpoint. Because you can't find a slope at an endpoint. It's a mathematical technicality. That's part of the theorem. Just memorize that, though. You don't need to know any more about it than that. You can't find the slope at an endpoint, therefore can't satisfy the mean value theorem at an endpoint. Give you a chance to write that down. Mean value theorem is never going to be satisfied at an end point. And one of the things the AP test writers often do is they create a problem where the end point comes into play, but you have to ignore it. So, okay, cool. So the mean value theorem says we're supposed to find which of these infinite points has a slope that is 0. So I want everyone to participate. Matt's already in. Hands up. How do I go figure out which of all of these points is going to have a slope whose value is 0? Hands up. Come on, talk to each other. How do I find which of all those points will have a slope whose value is 0? That's the mean value theorem. Let's go, Calvin.
You do the derivative equation and then become 0, or you set it equal.
Set it equals the better way to say that. So I have this. Here's something I like to do. I don't like dividing. I prefer to multiply. This is the sine of 1/2 x. Okay, 2 points for Callie. So I take the derivative. This is going to be the cosine of 1/2 x multiplied by the derivative of 1/2 x, which is just 1/2. Okay, when you see this, I'm going to pay everybody on this one. What should you be thinking when you see that? Hands, come on. I'm going to keep asking this question until everyone can answer it quickly, efficiently, accurately. When you see that formula, what should you be thinking? I'm just going to can do this every day until you're sick of it. Because this comes up so much. You just got to be able to look at it and know exactly what you see. What do you see? Now I'm terrified you won't raise your hand. Matt.
An equation that lets you find the tangent slope at any point.
Perfect. How many knew it? 2 points. Perfect. Okay, hands up again. How? Come on, focus. How? How do you use this to find the tangent slope at any point? How do you do that? That's what it is. But how do you use the formula? Don't overthink it. How do you use that formula, Colby, to find the slope at any point? Plug in the x value. How many do it? 0.2 for Colby. We have to do the opposite. We already know the slope we want to find. We want to find the slope whose value is 0. So hands up. How do I use this equation to go find the x that will produce a slope whose value is 0? Ada. So the equation equals to 0. So I write 0 equals 1/2 cosine of 1/2 x. How many knew it? 0.2 for Ada. Okay. Anyone need me to back up, talk about it differently, use different language, not get so fired up? I'm feeling healthier again. I'm ready to go. Don't do this. Okay. I told the story already, right?
Yeah.
Good.
0 over x. Like, so it's 1/2 0 times 0.
So you get?
Okay, so like cosine 1/2 x, so you plug in 0 for x.
Oh, 2 points for Hannah. But I want everyone to talk about it. You do not plug a 0 in for x. Why not? Common error, 2 points for asking. Why do we not plug in a 0 here? Come on, hands. Why do we not plug in a 0 here? If your hand is raised, give yourself 3. Mark them down, then put your hand down for a second. Different question that's related. What does this 0 represent? Hands, come on. The key to this class is keeping track of what each number represents, not just blindly plugging numbers in places. What does this 0 represent? Natalie looks thoughtful, but I think that's just Julia, please read.
Is it the slope, not the...
Perfect. This 0 is a slope. How many knew it? 0.2 for Julia. X is an x-coordinate. Just say yes or no. Does it make any sense at all to put a slope into an x-coordinate? Louder.
No.
Louder.
No.
Louder.
No.
It's not very loud, but whatever.
Right to you.
Listen. I save my enthusiasm for when it really counts. Look. Okay. We have reached the point in the class where you cannot just do things blindly. You can't go, oh, well, I take this number, plug it here. No, it makes no sense at all. Okay? This is a slope. You cannot put it in for an x value. Okay? I don't want Hannah to feel bad because she asked a really good question. So good work. Okay. It really was. It was a perfect question. Because everybody always asks that, Hannah. Hannah, every year, everybody asks that. But does it make sense? Awesome. Are we okay? Perfect. Okay, I want, it's what Julia said. I want this equation for some x to give me a value of 0. Okay, it's what I keep telling you all year long. In this class, you will not succeed by just manipulation, by steps. You've got to make sense of it. You won't even graduate from college if you can't make sense of things. I promise you. You have to make sense. I feel really bad. I know someone personally. He wanted to be a physical therapist. Like, really. He had a plan and everything. He couldn't pass college algebra. So he couldn't be a physical therapist. He had to go find a new career. Seriously. Like, you have to be able to make sense of things. They don't, okay, Honest truth, it's on the video, who cares? Honest truth, in high school, as long as you come, you sit, you graduate. Pretty much. It ain't like that in college. You have to be able to understand. This class, in my opinion, will help you more than any other class you're going to take in high school be successful in college. I really feel strongly about that. Because it's forcing you to think, not just do. Okay? I'm getting kind of fired up. We good?
Yeah.
Breathe. To solve this equation, you did it last year, but I'll remind you. I'm trying to get the x alone. So multiply both sides, divide both sides by half. But 0 divided by half is 0. Okay? We need the cosine of something to equal 0. We want the cosine of something to equal 0. So I draw the picture. So hands up. Where on the circle is the cosine going to be 0? Cosine is the back and forth distance. Where, come on, where on the circle? Where on the clock? And what numbers on the clock is the back and forth distance going to be 0? That's good work. Just the numbers on the clock.
Just the numbers on the clock. Times the clock.
So you're just doing it backwards. You're just doing it backwards. Hold on. Like right here, cosine is the back and forth distance. So if I'm sitting here, I have to go this far to get to that spot. So I have to go a distance of 1 to get there.
Oh,
It's the up and down.
right.
No worries. So here and here. Okay? How many knew it? Point. 2 for Nathan. So look up. Come on. I need this. Look, it's teaching you to think, not do. I need this to be pi over 2. Because the cosine of pi over 2 would be 0. I need this to be pi over 2. Because the cosine of pi over 2 is 0. Here's pi over 2. At this spot, I do not go back and forth at all. Preston, please.
So x equals 5.
So I'm going to write it down. So we got 1 over 2 times x has to equal pi over 2. So x is pi. Okay, please, Mike.
And you know that x is only 3 pi over 2 because you know that you did?
Say it louder.
And you know that x doesn't equal 3 pi because of the integral?
Listen to Maya, please. Say 3 points. 3 points. Look up. Well, Maya just did really good thinking. She said, I got to have a picture to talk about it. She said, we figured out that the cosine of 1/2 x is supposed to become 0. And we thought of the unit circle memory aid and thought, okay, so we need, this angle or this angle. So that means we need 1/2 x to either be pi over 2, in which case x has a value of pi, or we need 1/2 x to be 3 pi over 2. But solving for x here, you multiply both sides by 2. X is going to equal 3 pi over 2 multiplied by 2. So x would be 3 pi, but that's not in the interval. The interval we're looking for is not perfect. You didn't need to repeat anything. Awesome. Any questions? Anybody want me to give more details? Say it differently. This is an outstanding example of an AP question. They don't write a lot of questions where you just do one simple thing. You have to put together multiple ideas. But welcome to real thinking. Real thinking. Thinking that will make your life have meaning, I promise. My son said something really interesting. He said, really? pretty much any job is interesting for about 4 hours. I agree. I think it'd be fascinating to work at McDonald's for 6 hours. After that, I think I'd be bored to tears. I just would hate it. But for the first 6 hours, it's interesting. I think you should do the best you can to find a profession, career, major in college that's always interesting, okay? People ask me how I can teach calculus 7 periods in a row. Because I don't care about the calculus. I care that you start thinking. And then it's like super engaging for me. Like if I can see that you are thinking, I love it. If I can't get you to think, I have got to find another career. I've done 2, 3s, what the heck, so. Question? Cool. Anybody else bring a question with them to class from the first packet that would be helpful to investigate?